Welcome to day 4, homework for tonight, page 20 and 21. You can also be working on your problem set. Any of the proof reasons that we've done so far, the expectation would be that you have those memorized by now. So if you do not have any of the new reasons, or I should say not any, but if you don't have all of the proof reasons that we have done so far in Unit 8 memorized, that should be part of your homework as well. Don't leave those until right before the test. You want to be doing it now. Have your homework out and also your warm-up out, and we're going to pause the video for 2 minutes for you to do the warm-up. Should be a pretty quick warm-up. All right, alternate interior angles, we're looking for the zigzag. Now we have two sets of parallel lines. We have the top and bottom parallel and the left and the right parallel. So we could do a zigzag with the top and bottom going this way, and that would then give us angle 1 and angle 3 as a pair of alternate interior angles. Now, because we had parallel lines, we know that they are congruent, but it didn't ask us to state they're congruent. We just wanted to list the pairs. And we could have also done, we could have also done our zigzag going this way as well. Again, the two parts of the zigzag, the flat parts, have to be the parallel lines. So we could have angle 4 and 6 as another pair. And now for corresponding angles, those are sometimes easiest to pick out if you extend the line so you got the full 4 spots in the intersections. So angle 1 is in a top left. That would match with angle 5, which is in the top left. So we have angle 1 and angle 5. The other top lefts would be here, and those weren't actually in our original figure. Angle 2 is in a top right, and that matches with angle 6 that is in a top right. Angle 3 is a bottom right, there's no other bottom rights, and angle 4 is a bottom left, there's no other bottom lefts. So just angle 1 and 5 is one corresponding pair, 2 and 6 as the other. Alrighty, moving over to homework. We had one set of segments congruent, then we had some parallel lines. They were nice and already put the arrowheads on our parallel lines for us. So do a zigzag with those, and we get parallel lines implies congruent alternate interior angles. I numbered mine 1 and 2. You could have used 3 letters if you wanted. That gave us a side from given number 1, an angle from what I have is step 3. We need one more thing, so you got a reflexive property there. Two sides, angle is in between in our picture, so that was side angle side. Moving on to number 2, we had a set of sides congruent, BD and BC. We had some parallel lines, so I did our parallel lines implies congruent alternate interior angles to get 2 sets of angles congruent. You did have the option of doing just one set of congruent alternate interior angles, and then doing a vertical angles implies congruent angles to get another set of angles. If so mine here I have angle angle side. If you did angle A and E as your alternate interior and then did vertical, you would also have angle angle side. But if you did D and C as your alternate interior congruent and then did vertical, you would have had angle side angle. Next one is essentially the same proof as number 2. So you either did 2 sets of congruent alternate interior angles or one alternate interior angle congruent and a set of vertical angles. You potentially could have had angle side angle if you had F and L for your alternate interior and then did vertical angles. And the last one, number 4, extend those parallel lines and that transversal. It's easier to see The ones I labeled 1 and 2 are both in the top right there. So that's parallel lines implies congruent corresponding angles. And based on that and our givens, we have two sides and an angle in between. So that's side, angle, side. All right, so today we are going to look at proving parallel lines. So on our card, we're going to do the parallel line ones, but in reverse. So we're going to do congruent alternate interior angles implies parallel lines, or congruent corresponding angles implies parallel lines. Well, in order to get those congruent either alternate interior or corresponding angles, we often get triangles congruent first, and then do from day one congruent triangles implies congruent corresponding parts to get the specific angles we want, which will allow us to use our parallel line reason, but in reverse today. So let's start with our statements, reasons, and givens. So we've got two sets of congruent segments. We'll mark CE congruent to DE with one tick mark, BE and AE with two tick marks. Our goal is to get the triangles congruent, then use congruent triangles implies congruent corresponding parts to get a set of angles, which in this case are going to be congruent alternate interior angles, and then that will imply the parallel lines. So to get these triangles congruent, we can get some vertical angles there. That's an easy thing. So vertical angles implies congruent angles. And in my picture, I'm just going to label them 1 and 2. I'll mark them up in my picture. And we have two sides. We did get the angle in between. So this is going to be side angle side, congruent to side angle side. Like we saw on day one, when you make your triangle congruent statement and it's not the given, name the first triangle anything you want. So I'm going to go with CEA for the first triangle. Is congruent to triangle. Angle C is between the side with one tick mark and the side with no tick marks. So that matches with angle D in the other one because that's between one tick mark and no tick marks. In the middle is E, that was our vertical angle, so that just also matches with E. So if we did DE, then the leftover one is B. Since we just said congruent triangles, next we would want to do congruent triangles implies congruent corresponding parts. And that was from day one of this unit. This allows us to get either additional sets of sides or additional sets of angles congruent. For our purposes of getting parallel lines, we're going to try and get a set of congruent alternate interior angles here. So we want some angles that would be the angles of the zigzag. Now there's two ways I can do it. I'm going to go ahead and do it this way for my zigzag. I could have done it the other way and we could have used A and or C and D, but let's go ahead and we'll do angle A congruent to angle B. And then to finish our proof, A and B are congruent alternate interior angles. So we're going to do the reverse of our second last reason on our card. It's a double arrow, so we can do that. Congruent alternate interior angles implies parallel lines. And our statement is just what we wanted to prove, that CA is parallel to BD. So when you see parallel lines as your proof statement, we want to be thinking, okay, in almost all cases, it'll be get the triangles congruent, do congruent triangles and apply congruent corresponding parts to get a pair of angles that are either alternate interior or corresponding, so that we can then use the reverse of one of our last two reasons on the card. Going down to the bottom, number 2, go ahead and do your statements, reasons, and givens. Oops, I just wrote those on the wrong side. Let me fix those. So from our givens, we had two things congruent, so we'll put tick marks on B, E, and C, D. A, B, E, B's got to be the middle letter, so here's our angle. B, C, D, C is the middle letter, so here's our angle there. We'll put those arcs in. We want to get parallel, so let's get the triangles congruent, and then we can do congruent corresponding parts to get a set of angles that will allow us to hopefully get the segments we want parallel. So we've got a given there, the midpoint, we'll automatically do midpoint implies two congruent segments. And that's going to give us BE congruent to CD. Nope, sorry, that was the ones in the given. Let me fix that. If B is in the middle of AC, we'd have AB congruent to BC. Sorry about that. And we'll put two tick marks on that. Well, if we look at one of our triangles, we have two sides marked up and one angle. If we look at the two sides, the angle marked up is in between the two sides, which tells us that this is side, angle, side. If it was side, side, angle, we would have to try and get something else, because side, side, angle, remember, does not work. Our statement, we will name one of the triangles anything we want. I'm going to go with triangle ABE is congruent to. A was between the side with 2 marks and the side with no marks. So if we go to the other triangle, between the side with 2 marks and the side with no marks, that's B. In our first triangle, B was the marked angle, so that matches with C in the other one. And if we had BC, then D is left over in that top triangle. Well, if we look for a zigzag involving BD and AE, this would be our zigzag, but only one of those angles is in the triangle. So we're not going to try and get congruent alternate interior angles. In this case, we're going to try and get congruent corresponding angles. So we saw this the other day, but if we extend our lines, it can make it easier to pick out those corresponding angles. That angle right there is in the top right, so is this angle right here. So those are the angles we're going to want to get congruent so that we can eventually get BD parallel to AE. So I'm going to go ahead and number those 1 and 2 so they'll be easier to talk about. In our last statement, we said we had congruent triangles, so now we're going to have congruent triangles implies congruent corresponding parts. And our statement in 6 will just have angle 1 congruent to angle 2. And I'll mark those up with 2 arcs. Since those are both in the top right, those are congruent corresponding angles. So we're going to do the reverse of the last reason on our card. We'll do congruent corresponding angles implies parallel lines. We're pointing at parallel lines. The one we wanted parallel were the ones in our prove. We'll have BD parallel to AE. All right, moving on to number 3. Go ahead, do your statements, reasons, and your givens. So we have angle 2 congruent to angle C, so I'm going to put an arc on each of those. Now in our past 2 proofs, when we wanted to prove something was parallel, we got set of triangles congruent, did congruent triangles implies congruent corresponding parts to get either a pair of congruent alternate interior angles or a pair of congruent corresponding angles, and then use that to imply parallel lines. Well, we can't do that in this case because we don't have any triangles in the picture. So they also told us that BC is parallel to AD, so I'm going to put our arrowheads on that. Well, we eventually want to get the top and the bottom ones to be parallel. Well, something we can do with the parallel lines we're given is if we do a zigzag like this, we could get angle C congruent to angle 4. And that's going to be from parallel lines implies congruent alternate interior angles. And again, our statement will be angle C congruent to angle 4. So I'm going to put double arcs on angle 4 and angle C. And hopefully 2 different types of marks on angle C is telling yourself, hey self, we should use the transitive property here. So in step 4, we're going to do transitive property. So we're going to use statements 1 and 3 to help us get the new one. 1 had 2 congruent to C, 3 had 4 congruent to C, so now we have angle 2 congruent to angle 4 from that transitive property. And I'll put my double marks on angle 2 to now show that angle 2 and angle 4 have the same markings. Well, if I extend AB and DC, notice angle 2 and angle 4 are both in the top right of their intersections. Because they are both in the top right, that means that they're corresponding angles, and we have them congruent now. So we are actually going to be ready to finish this proof. We're going to do the reverse of the last one on our card. The thing we currently have is congruent corresponding angles. And what that's going to give us is our parallel lines. And the lines we're going to have parallel are AB parallel to DC. So notice, because we had parallel given, we did like we did yesterday, or last class, where we had parallel lines implies one of our congruent pairs of angles. And then because we had parallel as the prove, we also had to go in the reverse. So when parallel is given, you should have a reason somewhere that parallel lines implies something. When parallel is what you want to prove, you should have something implying the parallel lines at the end. All right, moving on to number 4. So because we have triangles in this picture where we're trying to get TU parallel to VS, this is going to be more like questions 1 or 2, where we'll get the triangles congruent, do congruent triangles implies congruent corresponding parts to get a additional set of angles congruent, and we'll purposely try and get a set of angles that are either alternate interior angles or corresponding angles. So from what we have so far, we have S congruent to U, so we'll put an arc. We have that ST and UV are parallel, so we'll put an arrowhead on each of those. Well, from that parallel, let's do our zigzag. The zigzag with that parallel would give us those angles of the zigzag. So I'm going to label those angles of the zigzag 1 and 2 so they're easier to talk about. And we'll do parallel lines to start, because that's what we had previously, and that's going to imply congruent alternate interior angles. With the statement being angle 1 congruent to angle 2. And I'll mark that up in my picture with 2 arcs. Keep in mind that parallel marking with the arrowhead does not count in getting triangles congruent. When we say A's and S's and A's, those are sets of sides and angles that are congruent to each other, not parallel. So because we have 2 sets of angles, we have to get a side for the third thing, because angle, angle, angle does not work. So they're sharing something, so we'll go ahead and do reflexive property. We'll have TV congruent to TV. And we've got 2 sets of angles. Our side is the reflexive one, not that purple marking. The side is not in between the 2 angles, because in between would be the side connecting the 2 angles. So we're going to have angle, angle, side congruent to angle, angle, side. Name one triangle anything you want. I'm going to go with STV is congruent to triangle. Now we got to be careful. Make sure to match things up based on how they're marked. S had our single arc, so that matches with U. T in the left-hand triangle has the double arcs. That's where angle 1 was. That should match with angle 2 in the other triangle, so that's where V is. So U, V, and then the T is remaining. So notice the T's and the V's don't go in the same spot in this case. So you don't just automatically put the same letters in the same spot. It's got to match with your markings in the picture. Okay, so we still haven't proven what we wanted. Our goal was to get some sets of angles congruent to eventually get TU parallel to VS. So let's just look at a quick zigzag with TU and VS. This would be the zigzag we'd have. So the angles of that zigzag are the ones that we want to get congruent. So I'm going to go ahead and call those 3 and 4. I didn't mark them up yet because we don't have them congruent yet, but we will in a second. We just said in our proof that we had congruent triangles, so now we'll have congruent triangles implies congruent corresponding parts. And our statement will get that extra set of angles, angle 3 congruent to angle 4. And now, because we have those congruent alternate interior angles, that allows us to get our parallel lines. So second last reason on our card, we have congruent alternate interior angles implies parallel lines. And our statement is just what we wanted to prove, that TU, it's parallel to VS. So one last one we'll look at, number 5. Go ahead, do statements, reasons, and givens. So tick marks on AD and CB. We'll also have arrowheads on AD and CB for being parallel. So let's come up with a plan for this proof. Notice we're not trying to prove parallel like we were doing on all 4 other proofs today. We want to prove a set of angles congruent in our triangles. So this proof, our end target is kind of like we did on day 1. Our goal is going to be to get some triangles congruent and then do that one extra step. Our congruent triangles implies congruent corresponding parts. Now, because we have a given of parallel, let's do a zigzag with those parallel lines first, see if we got alternate interior. Notice the angles of that zigzag are in our triangle, so we are going to do our parallel lines implies congruent alternate interior angles. To make them easier to talk about, I'm going to go ahead and label those angles 1 and 2. So we'll do parallel lines, implies congruent alternate interior angles. And we'll have angle 1 congruent to angle 2. I'll put an arc on each of those. So we currently have that blue side, the green angle. We can get an easy thing with reflexive. So reflexive property. Which would give us BD congruent to BD. using the reflexive and that blue side and the green angle, which is right in the middle, that's going to give us side angle side congruent to side angle side. We'll name one of our triangles anything we want. I'm going to go with the top triangle, go with CBD. And that's congruent to C was in between our blue side and the side with no marks. So blue and no marks would be A in the other triangle. B in the top triangle had our green angle marked, so that matches with D in the bottom triangle. And if we did A and then D, then B is our last one. And we're just about done with this. We just said congruent triangles. So we can now do congruent triangles implies congruent corresponding parts. And in reality, this allows us to get any sets of angles or sides in the two triangles congruent that we don't have yet, but we just care about the ones we want to prove. So we're just going to have angle A congruent to angle C. So you got the day for homework to be working on with any time left in the period, and you can also be working on the problem set. Have a great rest of your day.